What we're going to look at as we focus on the boiler room is this process-specific environment for creating pipes. Some pipes are already created based on the original 2D layout, and so now we'll take a look at the process for adding new pipes. Commands that select geometry are intelligently written to predict the user's actions. Notice how the center points of the circular edges are automatically found. No special filters or invalid key points can be selected. The shortest distance between 2 points is a straight line, but piping can't follow that rule. The start and end locations result in multiple paths. The Solid Edge gives us quick access to choose any of the most common paths. Solid Edge is optimized to how parts are stored in memory. By storing just key display data, Solid Edge allows the preservation of RAM. However, any part geometry that needs to be referenced needs to be loaded fast and easily. With a simple click, the parts can be loaded into memory and piping paths can be attached to them. As you can see, we have interference between our pipes. An interference check on an entire model would have revealed this to us also, which is especially useful when interferences are not so obvious. Paths can be accurately positioned and controlled with dimensions and constraints. Here we'll place a dimension to set the length and make a fast edit to eliminate the interference. Notice the graphic icons placed on path segment key points. These glyphs indicate how the path is tied down, so you'll always know what will happen when changes occur. For example, the parallel hash mark indicate that the segment will remain parallel with the base reference planes. Here we're going to remove that glyph off of 2 of the path segments so that we can add a gradient angle. We'll use the angular PMI dimensioning tool to create an angle between the path segments of 5 degrees. Now we're ready to add our pipes. Notice the dialog displays various standards and has the most common options. In some cases, the user may wish to create welded corners, and so any elbows can be omitted by selecting the option for pipe penetration cuts. Once the pipe size and type is specified and the paths are selected, the fittings are automatically placed. In this example, we need to enable the gradient and set the maximum gradient angle for our pipe. After clicking on Preview, Solid Edge adds the appropriate pipe segments between the fittings. Solid Edge includes a set of free pipe fittings, but you'll probably want the optional library as it contains hundreds of the most common components. Should any changes be made to the paths or parts they're connected to, the pipe runs will automatically update, such as changing our gradient angle, for instance. Once the change is made, notice that the paths update, hence the paths are resized and the fittings track to the new locations. Solid Edge understands the issues with large assembly design. Lots of parts need smart selection tools. For example, let's change the color of these new pipes to blue. As opposed to finding the pipes in a list or having to manually select them, Solid Edge has a useful command for selecting similar parts. With a few quick clicks, we can quickly grab these pipes and change their color. While this was a short demo, we can continue adding more pipes or begin documentation with 3D drawings or manufacturing reports listing cut lengths. Assigning designers to tackle plant design can be done from a file standpoint where a particular engineer manages a particular subassembly and so on. Zones in Solid Edge take design management to another level. We're going to focus on the zone called the platform assembly stage and show just the relevant components. Here there may be several subassemblies that make up this section. Trying to assign any particular designer under this scheme is nearly impossible. Zones enable design management from a graphical method as opposed to a file method.